Okay, move to the example related to ratio test. The example is the given series is just like it is 1 to infinity, and it is n factorial square divided by n square factorial. N square factorial. Okay, so here an plus 1 divided by an plus 1 divided by an is equal to, it is an plus 1 means n plus 1 factorial. Here we put I am writing n plus 1 factorial square. Okay, divided by n plus 1 square. Okay, and factorial multiply by an. Since an is the denominator, so this term will be reciprocal, just like it will be n square factorial divided by n factorial square. Okay, now it will be n plus 1 square. After simplifying, it is just like we can write n plus 1 square n factorial square. Okay, and n factorial n square factorial divided by, we can write n plus 1 square n plus 1 square. Okay, minus 1 and similarly n plus 1 square minus 2 and up to so on n plus 1 square minus 2n. Okay, and n square factorial, this one n square factorial. Okay, now we this approaches to 0, which is less than 1, as n approaches to infinity. Since it is less than 1, so this implies that the series is convergent. Series is convergent. Okay, we take another example. In this example, the series is n factorial divided by n square. Okay, here limit n approaches to infinity, an plus 1 divided by an is equal to limit n approaches to infinity, en plus 1, which means n plus 1 factorial divided by n plus 1 square multiply by n square divided by n factorial. And we can write limit n approaches to infinity, n plus 1, because n plus 1 and n factorial n square divided by n plus 1 square into n factorial. N factorial is cancelled out with n factorial, and if we check the exponent of n is greater than the exponent of n in the denominator is greater than the exponent of n in the, means it is n cube plus n square, and this is n plus 1 square, and after applying the limit we get infinity. This implies that series is divergent. Series is divergent. Another example. In this example, the series is n raised to the power n divided by n factorial. An is equal to n raised to the power n divided by n factorial. and an plus 1 an, which is equal to n plus 1 raised to the power n plus 1 divided by n plus 1 factorial multiply by n factorial divided by n raised to the power n. Okay, so after simplifying, how we will simplify it? N plus 1 raised to the power n plus 1. Okay, yeah, so it will be n plus 1. I am writing just like n plus 1 raised to the power n plus 1 divided by n plus 1 and n factorial multiply by n factorial divided by n raised to the power n. N factorial is cancelled out with. Okay, so this exponent will be just like n plus 1 raised to the power n divided by n raised to the power n, which is equal to n plus 1 divided by n raised to the power n. Okay, and this will be equal to this is equal to 1 plus 1 over n raised to the power n. It is equal to e as n approaches to infinity. Since e which is greater than 1, it means that the series is divergent. The series is divergent series. Okay, now we take an other example, and in the next examples we will also apply the ratio test. Once again, I would like to repeat, the ratio test is convergent for if the limit is less than 1, and it is of course divergent if the limit is greater than 1, and if limit is equal to 1, then this test will be fail. Okay, so the next example is in the next example given that the series is 2 raised to the power 2n minus 1, 2 raised to the power 2n minus 1 divided by 2n minus 1. 2n minus 1 factorial. Okay, so an is 2 raised to the power 2n minus 1 divided by 2n minus 1 factorial. Okay, and if I write en plus 1, it will be 2 raised to the power 2 into n plus 1 minus 1 divided by 2 into n plus 1 minus 1 factorial. Okay, so now we divide an and an plus 1. This will be equal to 2 raised to the power 2n plus 1 divided by 2n plus 1 factorial. 2n plus 1 factorial. Okay, so now we divide an plus 1 divided by an, which is equal to 2 raised to the power 2n plus 1 divided by 2n plus 1 factorial multiplied by 2n minus 1 factorial divided by, it will be 2 raised to the power 2n minus 1. Okay, and now it is very easy to simplify it. This will be equal to 4 over, okay, 2n plus 1 into 2n. So this will be equal to 0 as n approaches to infinity, which is greater than, this is greater than 1. So this implies that the series is convergent. Implies series is convergent. Okay,